Video is going to encompass section 6.2. We're going to be using our unit circle to solve a series of equations that we are presented with. We will start by what we came up with in our last class. An arc, which we'll call T on the unit circle, is the same as angle T on the unit circle. That arc, that angle, will take us to a terminal point, namely xy on the unit circle. And if xy is a point, let's just say a point rather than the point, or if we say it's a point on the unit circle built by angle t, if we get to this point by writing angle t, we can say the following. The sine of angle t is equal to the y coordinate that we land at. The cosine is equal to the x coordinate we land at. The tangent will be y coordinate divided by x coordinate, and then the three reciprocals will also fly. So we're going to use that, we'll tuck it away, and that's going to be a big piece of what we work with today. Before we get started, make sure you have your unit circle. You filled that out in the last class, or worst case, go ahead and grab it from the filled notes. These are all the different pieces of the unit circle. We're going to be identifying a bunch of these coordinates on the unit circle, and then we're going to identify, and we'll use radians this go around, the associated angle that takes us to that terminal point. So with the actual notes, the 6.2 notes, we're going to work in backwards fashion. So go to the last page of your notes pack. I'm going to give you terminal points on the unit circle. These are guaranteed to be on the unit circle. I want you to do the trig identities. We're going to work problem 3, and then we'll do problem number 1 up top. Terminal point, -5/13, -12/13. By the way, since x and y are negative, that happens to be in quadrant 3. My x value, we'll even write it out. This is a little bit of maybe too much, but that's okay. Y equals -12/13. The sine is equal to the y coordinate, -12/13. The cosine is equal to the x coordinate, -5/13. Y over x would give us -12/13 over -5/13. We'd have -12 over -5, and we'd walk into a value of 12/5. Can we handle the other pieces? We sure can. We can flip the sine to get the cosecant, -13/12. We can flip the cosine to get the secant, -13/5. We can flip 12/5, the tangent, to get the cotangent of 5/12. It's as basic as that. All right, let's look at one more problem. We're going to work the first one, -1/3, 2√2/3. Interesting numbers. Let's see what they will get us as we work our way through this. All right, again, x coordinate, and again, this is on the unit circle, so we're safe. X coordinate -1/3. That maps perfectly to my cosine. Take advantage of the low-hanging fruit. Go ahead and do your secant real quick. Flip this, -3/1, -3. Your sine, you're going to walk into 2√2/3. Your tangent, you're going to have what? 2√2/3. This is y over x, by the way. Over what? -1/3. We have fraction over fraction. The nice thing is the thirds cancel each other out. We're left with 2√2/-1, which is nothing more than -2√2. We've just found our tangent, -2√2. Let's get to our cosecant. Well, we better flip the sign. So cosecant is going to be 3/2√2. We need to rationalize, multiply by square root of 2 over square root of 2. What will happen to us? 3√2 up top. And 2 times √2 times √2. The two √2's become another 2. 2 times 2 is 4. 3√2/4. And if we flip the tangent, we're going to have, let's do it over here, -1/2√2. I just kind of carried the negative sign up here just to make it a little bit easier. Same thing, multiply top and bottom by √2/2. Downstairs, √2 times √2 is a 2. There's another 2 here. 2 times 2 is 4. -1 times -2, -√2/4. And so that's the basics. Know your point. Remember what? Your key takeaway. Know your relationships. Sine of your angle on the unit circle is the y coordinate of where you land. Cosine is the x. Tangent is y over x. Roll with those. You're good to go on these types of problems. So we're going to move back one page. And we're going to start solving for angles. This is some more of that 0 and 2 pi. Now on your notes, you're going to see a little bit more verbiage. This is kind of an older note sheet. But here is the key thing. We're going to be solving things of this nature. Find all angles, and we're going to state radians, 0 to 2 pi, for which the equation holds. We want the sine of t to be equal to 1/2. Well, the nice thing is, since we're on the unit circle, that's what we're going to be working with now. We are definitely on the unit circle. We know that what? We'll work with this problem. We know that the sine of angle t corresponds to the y coordinate on the unit circle. I'm just going to write u dot c. So, solving sine t equals 1/2 is nothing more than saying, would you please go to your unit circle and look for all the points that have a y coordinate equal to 1/2. Well, it turns out I can see one right here in quadrant 1, pi over 6. And look, brown color. Remember symmetry. 5 pi over 6 in quadrant 2. And I've answered this problem. Pi over 6, 5 pi over 6. Hopefully not too surprising. This sign is what? It's a positive. What does all students take calculus tell you? You need angles in quadrant 1, quadrant 2. From a unit circle standpoint, what do you know about quadrant 1, quadrant 2? That's where the y coordinate happens to be positive. Not a big surprise that pi over 6, 5 pi over 6 get the job done. Very similarly, problem 1. We can translate this as, hey, go look at your unit circle and tell me all the angles who have a terminal point with an x-coordinate equal to negative root 3 over 2. By the way, cosine is negative in quadrant 2, quadrant 3. That's where x, the x-coordinate, is also negative, quadrants 2, quadrants 3. I can start looking, and I want my x value to be negative root 3 over 2. Where can I find them? I can find that at 5 pi over 6. I can find that at 7 pi over 6. 5 pi over 6, 7 pi over 6. I'm done with this problem. Let's do a few more. Not going to do all of them, but with this general gist that you have here, you should be able to work through most of them. Secant of t equals negative 1/2. Well, finding secant on the unit circle is a little bit of a bear, but what do you know the reciprocal is of secant? It is the cosine. This problem now is just turned into solve cosine t equals what? Flip negative 2, you get negative 1/2. Gee whiz, just like question 1, you should be in quadrant 2, quadrant 3, and you're looking for what? Your x-coordinate to equal negative 1/2. Pull my unit circle back again. Where do I see an x-coordinate equal to negative 1/2? I see it at 4 pi over 3 in quadrant 3. I see it at 2 pi over 3 in quadrant 2. 2 pi over 3, 4 pi over 3. It's that basic. Cosecant of t equals negative 2 root 3 over 3. That thing looks a little bit ugly, but what's the reciprocal of cosecant? Sine. I can say sine of t equals negative 3 over 2 root 3. Just kind of flip things. That doesn't look too friendly on the unit circle yet. Can we rationalize? We sure can. Let's multiply by root 3 over root 3. What will we walk back into? We'll walk back into negative 3 root 3 over root 3 times root 3 will become 2. Excuse me, root 3 times root 3 will become 3. 2 times 3 is 6. I got negative 3 root 3 over 6. I can factor out or cancel out at least a 3 in top and bottom. I wind up with the negative square root of 3 over 2. My sine of t equals negative square root of 3 over 2. I need to be in quadrants 3 and quadrants 4. Where's my y coordinate equal negative root 3 over 2? I see it at 4 pi over 3. And I see it at 5 pi over 3. And that problem is answered. 4 pi over 3, 5 pi over 3. Last one we're going to do. Tangent of t is undefined. Well, I know that tangent is y over x. And we ask, how do you make a fraction undefined? The way to make a fraction undefined means you had to blow up your fraction. When a denominator of a fraction is equal to 0, your fraction blows up. Technical math term there, isn't it? In any case, this just translates into I need all angles on the unit circle that have an x-coordinate of 0. That's the only way. When y divided by 0 takes place, my tangent function is definitely going to be undefined. I need x equal to 0 to satisfy that. And on my unit circle, where do I see x equals 0? I see it at pi over 2 radians. I see it at 3 pi over 2 radians. T equals pi, pi over 2, excuse me. T equals 3 pi over 2. And I'm solved. A little bit more. Go all the way to page 1 now, which will look like this. Trigonometric functions of real numbers. I'm going to give you a whole bunch of angles in radians mode. Find their values on the unit circle. Most of these on the front page, you stare them down. Number 1, 2, 3, 4, 5, 6, 8, 9, and 10. Everybody but question number 7, those are angles that you already see on the unit circle. Negative pi over 6, well, if you can't see it on the unit circle, what's the idea? What's the smart thing to do? Go coterminal. Turn this problem into negative pi over 6 plus 2 pi. You're going to wind up at 11 pi over 6. So this problem to solve using your unit circle, you want to do the sine of 11 pi over 6. They're coterminal. Go look at your unit circle. Where's 11 pi over 6? It's right here. What's the y-coordinate? Negative 1/2. Sine of negative pi over 6 is negative 1/2. Again, a lot of these angles are in the unit circle. If it's a negative angle, go ahead and add. This will become the cosine of pi. Sine of 4 pi, well, there's a hint. Use a coterminal angle. Instead of adding 2 pi, this thing's too big. 4 pi is a lot bigger than 2 pi, which is the biggest value that we see on the unit circle. So go ahead and question 12, just subtract 2 pi. 4 pi minus 2 pi is, you'd be solving sine of 2 pi, which you can do on your unit circle. Negative 2 pi over 3, sine of negative 2 pi over 3. What would you do here? Go coterminal, add 2 pi, which is the same as negative 2 pi over 3 plus 2 pi, same as 6 pi over 3. So negative 2 pi over 3 plus 6 pi over 3, you'd wind up at 4 pi over 3. You're asked to find the sine of 4 pi over 3. So most of these problems pretty straightforward. Last one, 9 pi over 4. Again, gave you the hint, coterminal angle. 9 over 4 is a little bit bigger than 2. Go coterminal, you'll be back to where you would like to be. So work through all these problems. Most of them you should be able to do very quickly on this page. Our last item to discuss is some more complicated components. Some of them, again, let's look. 21, 22, 23, you can do directly right with your unit circle. There's a couple angles further down that will also be there. Cosecant of 3 pi over 4. Well, that's a little bit tougher, but what do you realize that you could do? Cosecant of 3 pi over 4 is 1 over the sine of 3 pi over 4. Can you find the sine of 3 pi over 4 on your unit circle? You sure can. On the unit circle, the sine of 3 pi over 4, is the square root of 2 over 2. So you would have 1 over the square root of 2 over 2. And when you work with this fraction, that becomes 2 over the square root of 2. You could rationalize that, running out of a little bit of space here, but I'm going to just bleed over into the next problem. 2 over square root of 2, multiply top and bottom by root 2. You'll wind up with 2 root 2 over 2, and simply the square root of 2. The cosecant of 3 pi over 4 is nothing more than the square root of 2. Tangent of 14 pi over 3. Well, this one takes a little bit more work. 14 over 3 is a little bit bigger than 2 pi, isn't it? As a matter of fact, it's even bigger than 4 pi. So when you do, I'm going to just use some real estate up here because you can do cosine of 2 pi over 3 almost in your sleep, I hope. 14 pi over 3 minus 2 pi, 6 pi over 3 gets me to 8 pi over 3, which is still too big. 8 pi over 3, what do I do with that? I take that another 2 pi away. I'm going to wind up at 8 pi over 3 minus 6 pi over 3. I will wind up trying to find the tangent of 2 pi over 3. Tangent of 2 pi over 3. Well, tangent uses the y over x. So let's go look and see what I have at 2 pi over 3. At 2 pi over 3, y is the square root of 3 over 2. And x is negative 1/2. I have 3 root 2 over negative 1/2. The 2's in the fractions both cancel out. I wind up with the square root of 3 over negative 1, or simply negative square root of 3. So all these problems, pretty basic. Again, you might have to do a little bit more work. You might have some reciprocals here. You might need to go coterminal. You might need to add 2 pi to fix a negative angle. If you got an angle that's too big, you're going to want to subtract 2 pi. Use your x over y, y over x's, so on and so forth, whatever you happen to have. Use your reciprocals as we did with cosecant. Use your y over x for tangent. You see any cotangent problems? Hey, if you see a cotangent problem, 7 pi over 6 happens to be on the unit circle. That's problem number 31. You could look for x over y there. So this is the gist of this lesson. You've seen most of what you need to solve all these problems. An answer key will be loaded for you, filled in notes you'll be able to see and check yourself. Bottom line, work all these problems. You also have some textbook homework. And once you're here, you'll be very successful with this piece and in very, very good stead for what we're going to do next.